So let me first tell you a bit
Yeah.
about the format of this interview, right? So I will give you a question,
Yes.
right? It could be a one-part or a two-part question. Secondly, the interview
Okay.
after 45 minutes, we will have a feedback session where I will give you my feedback and you may give your feedback about this interview, whatever the feedback you have, right?
Yes.
And then we will end it.
Yes.
Sounds good?
Yeah.
Cool. So
Yes. Yes. Fine.
let me give you the question.
Okay. So we're starting on 6, maybe 22. So the
Yes.
the interview will end on maybe,
For
what is the time? 7:05 or 7, I think.
yes, it's just at 45 minutes too. I'm bad with maths, it's taking
Yeah.
me some time, but
After
yeah,
that,
at
50.
45 minutes. Don't worry. So
Okay. So
I'll
so
give
so
you
end time will be 7:05, right?
yes, so 22 plus 7
7:05
7.
p.m.
So let's make it
Okay.
8:25, right? 8:25 plus 40 minutes makes it 7:05 plus 5 more minutes 7:10.
Okay.
Right? We will stretch it to 7:10. Cool.
Okay.
Yeah, let's make it 18:25.
Yes. Okay.
So this is your question. Just let me know
Okay.
if you have encountered this question before. I can change the question.
Okay. Okay. Just let me read just 1 minute.
Sure,
Given a
sure.
root of binary determinant, left subtree of node contains. So here we are asked. You asked that, well, if it is a valid BST or not. Valid BST is all the left childs will have a lesser value than root, and yeah, I encountered earlier also in lead code.
Right, right, right.
So it so means you want my like you will ask other question, or I have to solve this one only if I encountered.
So if you already know the solution, then I would say we change it. If
Yeah,
not, then you can continue from this. So, I mean, this is not actual
yeah,
interview, so I'm counting upon your own discretion.
yeah. Actually, I solved it many times, like 2 3 times in last year.
Mhm.
Coded also, like it's a recursion. DFS will do, and will check if my current route is
Mhm.
uh,
Yeah. Hello.
yeah. So what I'm saying, I just pass a route into the DFS function, and I'll check if I am going left, then it should be bigger. The parent should be bigger than the current value, and if I am going right, then the current value should be bigger than the root, and if it is not, then it will return the false. Like that, some solution will be there,
Right, right,
and this,
right.
yeah. So maybe new question will be better.
Cool. So, what kind of question would you like me to ask?
Maybe if you have like you medium to hard, not that hard, but medium to hard question, I would like any. So if I say
So,
I want this question, then next any question you ask, will that if even if I encountered, will do that.
not a problem. I just want to know that if there is any particular topic in your mind which you would like me to ask you. Any,
I want to simulate totally random, so that's why.
you
Uh,
want it
uh,
totally random.
you, yes. Any means all parts, all topics I have covered. So you ask any next question, will start.
Mm,
Maybe it
cool,
would be
cool,
better.
cool. Let me. So, how about have you done the problem about least common ancestor?
Yes.
In binary search tree?
Yes. Yes, I have done using hash sets. Maybe if you ask me, is yeah, I have done uncoded also earlier.
Uh-huh.
I'll be able to figure it out a solution also.
Okay. And how about least common ancestor in a an array tree?
An I didn't done as of now.
You haven't done it on an array tree. No?
Yeah, in an I didn't.
Let me just remove this question. Thanks for thanks for the honesty. So let's start with the BST and then we will move to an analogy. Okay, I want to check your first approach first in BST.
Okay. Okay.
So it would be a two-part question in our case, right? And since we have
Okay.
wasted some of the time, so it would start now.
Okay.
So we need to find least common ancestor in a binary search. How would we do that?
Okay. So we have a tree and we need to find least common ancestor. So what will the input will have how many nodes? Like it will have at least two nodes. It should have, right, to find the common ancestor. So if it is having more than two, or how many nodes we need to find the common ancestor.
So yeah, let me give you. So the input which you will have is input. You would have node, right? You would have node one. So and you have to find least common ancestor of node one between node one and node.
Okay, so the input will look like that only. Root node, node one and node two, and
So you may define
okay,
your data structures in any way you want.
okay.
Right? Yeah.
So I'm assuming that the node will be a object, a Java object, a class called node, and in that will have left and right margin, and whatever the data, it may be like uh, it may be integer also. So let's say node is a class and we have integer data left and child and a constructor. Then uh, okay, that's fine. Now then the first solution which is coming in my mind is we'll just do a DFS, a depth first search, and we'll
Mhm.
have a set of nodes.
Mhm.
Okay, just give me 2 minutes. I'm just thinking.
Yeah, sure, sure.
Six. So for each of nodes, I will do depth first search twice, and I will have two hash sets to store
Okay.
the path till that node. So for first node, I will traverse till I find that node, and
Mhm.
I'll stop there. Then I will again depth first search for second node, and I'll stop there, and I will save all the nodes which are coming in the path. Let's say if we have can we use the whiteboard? We also have a whiteboard here, right?
Sure, 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 sure.
Let me ping in chat. again in chat, in Google Meet chat, you will be able to see.
But it is actually a good idea. I have never used a Jamboard before for
Yeah, I
node.
just seen as of now. Okay, so you can see right that board. So
Yes.
let's say we have node here, and I will draw just binary tree, simple binary tree, and we have this tree, and let's say we have 5 here and maybe 10 here, and if we want to find the least common ancestor of 5 and 10, so I'll just do a binary, sorry, but DFS for 5 and DFS for 10 separately, and I will maintain two hash sets to uh, store their paths. So let's say this is 1, this is not 1, actually this is 6, uh, this is 7, and this is 5, right? So 657 will be stored in first hash set.
Okay.
675, sorry, 675 will stored, and for this 6, 9 and 10. Okay, 6, 9 and 10. So then I'll have this both hash sets, and I'll iterate both hash sets from starting until I find different values in them.
Mhm.
Okay, so here I start from the first pointer. I have the same node. That means it is having common, the path is common in there. Okay, then I'll go to next, and I find that the both nodes are different. So that means the previous node was the least common ancestor for uh, both nodes. So
Mhm, mhm.
this is my approach. Yeah. So if
So
we'll have some, yeah.
uh, what if you have a node like this? What if you have a tree like this?
Okay, so
It is firing
linear
results.
linear tree, non, yeah.
This is also binary search tree.
So yes, so here in this case, this option would work, but again we will okay, least common ancestor for, let's say here 5, 6, 7, 8, and let's say we have to find 6, least common ancestor was 6 and 8. So our paths will look like, if I go with my approach, then 5, 6 and 5, 6, 7, 8. So here the edge case appears that if the any of the hash set or list is uh, null, and then means it it got empty, or we reach the end of the hash set, then that would be the least common ancestor. Like in this case, we reached at the end and we didn't find any different nodes, right? So whenever we reach there in any of the hash set, then the previous node which was there was the least common ancestor. So in this case,
But then
6 itself
six,
is a,
yeah, six
yeah,
cannot be
yeah.
an ancestor
The
of six.
problem is 6. Yes, yes. So I think in a hash set will not have 6, because once we find the node, in the algorithm will not add the node which we are finding. So here also we added till 5, right? Here was 5, right? So it should not be added till the parent we should add only. So 5 will not be there, 10 will not be there. So here also 6 will not be there, and 8 will not be there. So we'll go till here 5, 5. So this will be the least common ancestor for both. So we should not add the current node in the list, means sets.
Mhm. Cool.
But one issue I'm seeing here is it should not be the set also, because set will not have any ordered value. Set will just keep unordered things. So we should have a linked list type of, or a list, array list for to save this, because
Right.
we want to preserve the order, right? So
Right.
the one correction that
Right. Right.
here, yeah.
So, what would be the space and time complexity for this?
Yes. So as we are saving two lists, so which will save, in worst case it will be saving all the nodes in the list. So each of the list will take maximum of, if n is the number of nodes in the binary tree, then each list will take n space. This will also will take n space, and DFS also uh, do with recursion, it will, or iteration, in both cases it will take a space of n. The recursion stack will also take the space of n. So if
Right.
we take an worst case scenario, so it will be big of n, 3
That
n's,
is
but
the
we'll
space
omit the
complexity.
constant, so space will be of n. Yeah, that will be the space complexity, and time so be n, because we are iterating, we are just traversing the whole tree twice, so it will be 2n, which again comes to the of n.
Mhm, mhm. Right. Right. So, one thing here, if we consider this as a binary search tree, right? If we are considering it as a
Yes.
BST. So, keeping that in mind, we can see that there are certain constants which are coming into play, even with O complexity. Do you think we can improve it?
Yes. Yeah. Yeah. So if it is given that binary search tree, so we'll just go in. If it is balanced, also if it is uh,
No,
balanced,
it
then
is
in
not
worst case
balanced.
it will
It
take.
is
Oh,
it is not balanced.
yeah. In
It
that
can be
case,
unbalanced.
like, yeah. So like this, we have unbalanced binary
Yes.
tree. Then the time complexity will be of n. But if it is somewhat balanced, so we can achieve a log of time complexity for that, and space also, because if it is balanced, then we'll go in the direction where we want to go only, right? We'll not go in every direction. We just do a binary search on the BST, we'll reach that node, and that will take only log of n time, a log of n time to reach. So in unbalanced tree, we'll still need O of n time and space, and in balanced tree, we'll need O of log n and space and time complexities.
Right. So the point here is that we cannot control whether the tree is balanced or unbalanced. So I'm moving to the
Sorry.
second. I'm moving to the second board. Right. Are
Okay.
you here?
Hello. Yeah. Yeah.
Yeah. I mean, cool. So first thing is we cannot control whether it is balanced or unbalanced. So the first thing is we are creating a list, and
Yes.
then we are doing a DFS. So this thing is taking quite a bit of memory. Right? And the entire solution, we are not using the property that it is a BST. So do you think you can use this? You can use this fact that it is a BST and implement a solution for it.
Yeah. So given that it is a binary search tree, we can do a DFS, binary search in the solution, as I said earlier, to achieve the log n time.
So how do we do that? How do we do
We'll
the
just
binary search?
yeah. How do we do? We'll do a DFS again. The same DFS will do, and we'll just
Uh-huh.
call left. We will not call left or right branch. We'll just
Uh-huh.
call, if the node value is lesser, then we'll go for left. If it is bigger or equal, then we'll go for right. So in that, that's how we'll achieve the log n time. And one optimization I am seeing now
Mm-hmm.
in the space, like in complexity wise, it will not help in complexity wise, but the second list, uh, I think we don't need second list actually, because using the first list will just pass into the. I will use the first list in second traversal,
Okay.
and we'll see that the first. I am thinking that if we can use this the first list in second traversal or not. Uh,
So you just said that we do not necessarily need to uh, do DFS. I mean, what you said is, I mean, we do not need to keep. We just need to go to what the either of the sides where it actually needs to go, depending upon whether the current node is greater than or less than the node which we are trying to find, right?
yes,
So,
yes,
considering that particular fact, do you think we should
yeah.
need, we would need, we would need to create a list? So, I mean, yeah, come back to the other board. So, click on right hand side on the top, right arrow on top. It would take you to the other board. It's a fresh board. You can
Right
forward.
arrow. Oh, okay, okay.
Yeah.
Yeah, I am
So,
there.
yeah. So just uh, try to create another binary. Let me just create it for you. This is the binary search tree. You're going in the right direction. These are the nodes. We will give 5 more minutes to brainstorming, and then we will move to coding. Okay.
Code. Okay.
So
So
let's say we have to
okay,
find least common ancestor between 6 and 8.
okay, okay. So let's say I'll go with the two list solution which I mentioned earlier with binary search. Okay, so I'll
So
come to the root for first
two
traversal.
list. Sorry. Let me interrupt you here. So the two list solution, we can see that it works, right? Uh,
Yes.
what I want you to think about is think about a solution where you are using the property of binary search tree as well. I mean, if you want to still use the two list solution, go with it. But just show me how you are going to use the binary search tree. The one you said you will be comparing the value of the nodes.
Oh, okay, okay.
I'm interested in that solution where you said that you would be comparing the value of your node with the
Okay,
other.
so first I will go with a two list solution. Then I have other solution in my mind which I need to think more. But I will first go to the two list solutions
Okay.
to explain. Okay, how I'll do that. So I will need two traversal and two lists. So first I will explain that. So in the first traversal we want to find for six, right? The
Yes.
path for six, and in second path for eight. So first I'll go to root and check if seven is greater than or equal to root. So it is obviously shorter. Then I'll go here
Mm-hmm.
and I'll add 7 to my list.
Mm-hmm.
Then I'll get 5. Then it is 6 is greater than 5, right? So I'll go to here and add 5 to it. And as soon as I found a 5, I'll just stop the recursion there and I'll return. Okay.
Mm-hmm.
So here we have the list for 6 is 7 5. Then start second traversal. Again I'll go to root node,
Mm-hmm.
go in right direction because 8 is greater than 7. So I'll go here and add 7 to the list. Then here 10 comes, so it will come here and it will go left because 8 is shorter than 10.
Mm-hmm.
And that time I'll add 10 to the list. Okay. Then I'll find it and I'll just stop there and I'll go. Then I'll stop the recursion and it will stop. So I'll have 7 5 and 7 10.
Mm-hmm.
we'll just start comparing. We'll just start comparing the two lists, and while we either of the list is empty, means getting the last length, or the the node value is different. Means if it is not both lists are not equals, then we'll just hit till the lesser length, the minimum length of them. And if we have if we find the different value, the last which we find was the uh, common ancestor. Okay, let's take the example of where we have the unequal list also. So if you want to find 4 and 10, so the list will look like 7 and 5, and only 7 for this. So here we'll go, and here obviously we'll hit and before this. So whatever we are pointing now, it will be the least common ancestor. And yeah, this solution will work using the binary search property, BST property.
Mm-hmm.
Does that make sense for you?
Right.
Like,
It does. 2 more minutes, Tarun. Can you think of anything by which we do
else,
not
okay.
need to use list? We'll give 2 minutes and then we'll
Okay.
jump back in. And while coding, if you are able to, if it strikes you, then we can discuss that.
Okay, okay. Yeah, yeah. So one more solution without list I was thinking about was, I'll just start searching for both values in the DFS, and I will in DFS I'll check if both values are going in the same direction, either in the left or right. If they are going in two different directions, one is in the left or other in the right, or vice versa, then I'll stop there, and that will be my parent, least common ancestor. So in that case, will not need any list, and only one DFS traversal. So how it will work? In DFS function, I will just pass two nodes, like we already have,
Mm-hmm.
and in the function itself, I'll check if the root node is. I'll compare both nodes with the root node, and find out how, if they are going in, means if they are both less or both are greater, that condition will satisfy our problem.
Okay.
Means if both are less, then they are going into the left direction. If both are greater, then they are going to the right direction. If they are not going to the same direction, then we'll stop there, and the current node will be the root node, the sorry the least common ancestor node. So let we yeah. So you want any example for that? Like, I
So
should
yeah,
I run?
I got your point. So how would it satisfy this case? I'm clearing this frame, okay? How would you satisfy this with this solution? You have to find it between 7 and 8. So how does this work for this solution?
Okay. So in this case, we'll go like 6 and 7, the node which we want to find the least common ancestor. So we'll here we'll go both in, and right for both values. Once we can check also, we can do it. The current node is equal to either of them, and we'll stop there, and my previous node will be the parent. So while traversing in any direction, we'll just store the last value in any global variable, and if that condition, this condition will be the top, means this condition will come before on, if you found either of the value with the current node, then you stop there, and the obviously this will be saved as a list LCA node. So the
Hmm.
the solution is, we I if if I find any of the node in my current as a current node, and I'll stop there without changing the pointer, the LCA pointer.
Mhm, mhm. Okay, let us start. Let us check
So
the implementation.
okay, so should I start code now?
Yeah, sure.
Okay, so uh, uh, I'm at the this Google Doc page. Okay,
Yeah, yeah.
now let's say our method will be our class is node. I'm assuming our class name is node,
Mhm,
and will return the node object itself, the pointer to the node, and our method will be list get lca
mhm.
b is 2, and and argument will be same as you explained. Sorry, node root. Should I make a class also, or just should I
Whatever sensible. Fine.
node node 2, and in will have a lca variable also, global variable, let's say, and it will point to the null. So the assumptions are here the node 1 and node 2 will be inside the BST. There will not be any case for this code. I am assuming like that. For this code, node 1 and node 2, I will that is a guarantee that I'll find in that BST. So assuming that I am coding this. So first we need to find if current root is current node is null or not. If it is null, then we'll just sorry, it's Google Docs. Yeah, autocorrect.
Do not worry about
It-
do not worry about the
Okay,
capitalization.
okay. So if it is not null, then if root dot, let's say value will be the integer data of it, equal to node one dot val, or root dot val equal to node two dot val. We'll just again return. Actually, the return type I would take as a void,
Okay.
or let's say means will need a helper method. Let's say this is the helper method. Main method will be something else. I will call just and let's uh, let's consider this method as a helper method only just for now. So we'll just return from here. We'll also return,
Mhm.
and we can merge this case with the first case.
Okay.
Return, and now if root dot val is greater than or equal to assuming this greater equal value will be after my if I duplicates, then like if we have 5 and 5 in my and I'm assuming that the the duplicate node will be coming in right side of my tree. There is an assumption there. Okay, so if root dot val is greater than node 1 dot l, and root dot val is greater than or equal to not root dot val, then we'll do we'll change this name as DFS for just for we'll need to go to right root dot right node 1 and node 2 as it is will pass.
Mhm.
Else, if otherwise will go to left. If it is sorry here root dot val is greater, then we'll just need to go left.
Mhm.
Okay. Now root. Just give me 1 second.
Sure. So, what are you thinking? What
Yeah.
what did you mess
Just I
up?
think it's yeah. I will call this condition only. So it is right. If the root dot root is greater than node 1 and
Mhm.
node 2 also, then we'll go to just left. And else if dot both the values is greater than root, will just go to right.
Mhm.
In third case, in which either of them is not the same direction, will just not do anything.
Mhm.
And will stop here. And our root just said to the LCA, and in this is the I mentioned this is a helper method. We'll just create a main method from where we will call this DFS,
Mhm.
and it will return a node, and which will be called as get LCA, and we'll just call this DFS root node 1, node 2, and will return the LCA.
Okay.
Yeah.
So
So I think it will let.
what
Okay.
I see here is that the signature of your main method and your helper method are mostly same.
Yes, that is the thing I also was thinking. Here, the problem here was what I was thinking. If we hit this condition, so we'll have a pointer to the root, not to the parent. Let's say in the root will be like in case of that the flat binary tree. Five
Mhm.
six seven eight was a binary tree in the right,
Mhm.
and we hit the condition where the root will be 6 and our node 1 will also be 6. So here what should we return, I was thinking. So just I created so the signature is same. We should do something to return, means we should have only one method here. I understand that, but how what should we return here if we hit that condition? We should return parent, or we can return null also, but null will not be the good option.
I mean, I would let you decide what you want to return there, but What would have you returned if it was a production code which you were working?
Okay, so
When I say production code, it's not, I mean, the coding in production, but you're coding for production.
yes. Just a couple of moments. I know on to what I would do. Maybe I'll change the signature of the function and I'll have a root. Sorry, a parent, not parent,
You
and
give a
I'll return
parent
a
name.
parent here and
Why don't you do a dry run of your solution and see what it actually returns? So
sorry.
why don't you do a dry run of your solution? Let me just why don't you do a dry run of the solution? See what it actually returns.
Okay. So first we'll start. And what is node one and node two here?
Just take anything, like whatever
Let's say
suits you.
take 7 and 9.
Okay.
We'll start from 8, and 8 will come here. 7 and 9 will come here. Root is not null, and both values are not equal to val. Also, right? 7 and 9. So it will go here. LCA will be the root. Root will be the 8. Then we'll check if both root dot val is like 8. Here I'll write the condition. 8 is greater 8 is greater than equal to no, which is 7, and is true. But
Do we need this
our
greater than equal to? So I mean, do we need this equal to
a,
be? Do we need to check if these two nodes are equal as well?
no, actually,
If yes, then
if
we'll
it is
assume
equal,
NP.
then no. I think it will not be the case because we
Ah,
already checked this equal here. So
okay.
because if them if either of them are equal to the node dot well, then we would have already returned. So we can remove this equal here.
Okay.
So we'll just check if 8 is greater than 7 and 9 is also greater than 7, which is false, and which is false will come here, and this condition will also be false because both are them are not greater than 8, right? So this DFS will not also called. So both recursion will stop, and the recursion will stop here. It will just return from here, and we'll just return LCA, and LCA in LCA will already have 8, which we set here, right?
Mm-hmm.
So in this case, it will return this node.
Cool.
Let's say in one more try run, we'll do for 9 and 11. For that, in that case, 9 and 11 both are greater than the node. So it will go, the DFS will go again here,
Uh-huh.
and the root node will be the 10 because we are going to the right. So
Mm-hmm.
current LCA will be 10 now, and it will check if both are less or both are greater, and then this both condition will be false, and a recursion will stop there, and current node will be the 10 in LCA in LC variable, and from here we'll return the 10.
Cool.
So the thing I stuck at what should do, like dry run is fine for you, right? Or should I dry run
Yeah, dry
any
run
other
is fine.
example?
Dry run is fine.
So the thing which we stuck at, which I stuck at is what should be the, if both signature are same, then what should we do? We one
Both
solution
signature.
miss one, yeah.
Yeah, that's fine. Don't
So
don't
what
worry
we
about it.
what
Don't worry about it if both the solutions are
yeah,
signatures are same. I'll discuss it. The next thing
okay,
is what is the space and time complexity for this solution?
yes. So as we talk about time complexity here, so we are using given that the binary search tree is balanced or not balanced, whatever the if I condition worst it's not balanced and it's a straight line like list, then the time complexity, if nodes are n, number of node is n, then time complexity will be in the range of n, and in if it is balanced, then it will be of log n, log base to n. Then the time, the space, right? So space will also be the same.
Mm-hmm.
Space and time will be the same because the space we are not taking the two lists obviously, but the DFS recursion stack will take in worst case, and in the case of that linked list type of binary tree, and in balanced tree it will take log n of space.
So can we get rid of the extra space?
Extra space. So you mean we don't want to go in? Okay, so if you want to get rid of space, then we can do I think BFS will work or not here.
Does
We can
does
solve it through
doesn't
iterating.
BFS take extra space?
Yes, it will take. Yes, BFS will almost it will take same space because we need to for this particular case. I think it will not take that much of space because in BFS, let's say for a dry run with BFS, if you do, I'll just check. I'll go in only one direction. I'll not have to store all the whole level in the let's say priority queue or any queue like that, which we generally use for BFS, right? So
Okay.
in one iteration, I will just go in one direction. So here, if I have seven or let's say five or seven, so I will just check the node one and two, and I'll select only one node, which is six.
Mm-hmm.
Then in next iteration I will find that both are in going in different direction, so I'll stop there. So I think if you use BFS for this particular case, the time, the space will be constant, only one node at a time we are saving, not any queue. In normal BFS we use queue, but here we can just use one
So
node variable.
you are considering this tree, right? So what if we have five, two, five, under seven we have more. So it can be a huge tree. So let's say if the height of this tree is something like, so let's say the height of the tree order is of order uh, 10 raised to the power 4.
Okay.
Your DFS would fail. Even your DFS would fail. Right?
Uh, height is 10 to the power 5, then you're saying DFS would.
Yeah, I mean, it would be a stack overflow exception.
Yes, yes. So in that case, we can use my second solution, which I through a BFS in iterative manner we can do, and we'll
Even with your
saving.
BFS, right?
Uh,
You would be again be going. You, how would you be going down in BFS? Would it be you would be
in BFS, we'll start with, yeah. In BFS, how it will do? We'll start with root node,
Mhm,
okay, which is just one node. We'll check the same conditions here and select one either of. We'll have at one point of time we will have in our pocket to check only two child nodes.
mhm,
Okay, so from starting we have only 6 and 10 to check which way I should I go. So in BFS we'll select only one either of them.
mhm,
Okay, and I'll save that in the same variable like LCA.
mhm,
Like if we have if we have to find two five answers LCS,
mhm,
so the answer will be 5. But how we'll do? We'll just start at 8
mhm.
and check whether we have to go using these conditions. So uh,
Got
both
it.
are
Got it.
less, so we'll just select.
Got it. Can you try to implement it?
Sorry.
I got your solution. Can you try to
Oh,
implement it
okay.
for me?
Okay. Okay. So instead of DFS in same method where it goes. Okay. So in same method
Write a
we
separate method if
will.
possible.
Okay. So just let me copy. I'm writing it into the next page. Okay.
Yeah,
Get
sure.
LCA with this naming. Namings I
That's
am
fine.
just
That's fine.
not
That's
worrying
fine.
about. Okay. It's not in correct manner, but let's. Okay. So here I will have a root, right? So I'll just use that root, and I'll have these conditions while loop I will need while root not equal to null, and then yes, I'll think about the condition just in while. Just let me complete this. Root will equal to root dot left. So the left thing is the while here. How do we stop the condition? The thing left here is this. So if root is null, then stop. I don't think it will null anyways because we'll find either of the node in this. So I'll just omitting that condition. If it is null, then we'll just return from here only. Okay, I'll write this later. Just we finish with this condition first. So root is not null, and while root dot well not equal to root one dot well, and then it should not be equal to the node also. So we'll enter this, and
Cool. So
also
we
in
have
this else if yes, just let me
okay.
finish this.
Complete it.
I think here
Complete
we
this else
also should
part.
pick. Yeah, here also I should break.
Okay. Okay. We are out of
Yeah,
time.
I think it will work.
We'll we'll stop here.
Yeah.
Do you have any questions?
Oh, okay. So interview is over, or I need to.
Uh, just if you have any question, then we will stop the interview. Just the
So
if you have any question regarding this interview, or any if you have any question regarding Google or any other company, any particular question that I can answer.
yeah, Yeah, so to save time, I will not ask any question regarding to save time for feedback. I will not ask a question.
Cool.
Otherwise, I would have asked Google things like how things are done in Google. I'll find later, but feedback part will
Cool. So I'll give you the feedback.
do.
Before asking you for feedback, I would like to ask you this. You have certainly solved this question before, right? But I want you to check if you have
Yes.
done this iterative part as well.
No, no. It's a. I have done this very long back, using two lists only, and I was not remembering the solution anyway. But this iterative part I just thought now.
Okay. So I mean, this is just for my information. My feedback would I would give you feedback from an interviewer's perspective. So
Okay, okay,
let's come to the Jamboard and first sheet of the Jam.
okay.
You hear?
First Jamboard or second?
First.
Okay.
So the first solution which you gave, right, where you would have done a DFS, right? So one
DFS.
thing, yes, so what DFS and you would have saved the list, right? So one thing you missed here was uh, when you're traversing through the list, say you are on six, then you go to this, then you go to this, right? So
Okay.
what you should have said is we would have to find the node, exact node which we would have got, which we would have required. And once we have
Hmm.
received that node, then when we move ahead, move up, right, we would be saving our nodes. That was the problem with the solution, right? Because I'll give you the reason. Because if you by chance go to this direction and you keep saving your list, it would give you a wrong solution. Though I could get what you were trying to do, right? I did not raise any questions there because it could have derailed you, but there is a chance that the actual interview may ask you questions,
Hmm.
right? They could have pointed out this part. Even I should have pointed out now that I think about it, right?
So, but the one point is, do we actually go in wrong direction anytime? Because
For the first solution you were not using you were not checking if if n
BST. Okay.
is greater than or less than root, right? So since you are not checking that,
Actually,
so
okay.
you so this solution works, right? This solution would have worked. We would have gone to an so this solution would have worked for an NRE tree, but even for an NRE tree, the approach which you mentioned would have failed, right? So
Yes, actually, yeah.
right, so you should have said when we go up the stack,
Hmm.
when we are
Then we would have
unwinding the
saved
stack, then
the.
we have to save the one,
Okay.
right? So this is the first thing
Yes,
which I
yes.
noticed. The second thing which I would say is that most most of the solution. Let me give you the positive part. Sorry, first. The things which I liked about it was that although with the first solution, right, which you gave here, things went a bit towards south, right? They could have gone towards south. I should have taken it bit, tried to confuse you a bit, but I did not. Not confuse you, but ask you a question around it. However, what I liked a lot about you is if you come to the second Jambo, right? Uh, you
Hmm.
considered so the previous thing which was here. This sorry, not sure how to bring that up, but yeah. So what you did was when I asked you to optimize it, you did optimize it, right? You used the property of BST. That was really good,
Yes.
right?
Yeah.
that is I would say that I really appreciate it. Then after
Yeah.
doing that, I was continuously trying to push you to go to a more optimized solution where where you wouldn't have be required to use a list, right? So you even went
Yes.
there. So what it shows me is that you are pretty flexible, right? And you are agile in a stressed situation. So you can move in any direction you want, right? When in a stress
Yeah. Yeah.
situation,
Yeah.
that is the impression which it gives, right? So the next thing is, which I liked a lot, was that uh, the the variable names which you provided, right? They were really good. You did not use P,
Oh.
Q,
Okay.
N, T, right? Although
Yeah.
not
Yeah.
not a big thing, but still I appreciate that you use those variable names, right? And another thing,
Yeah.
yeah. So this is mostly what I considered, and it was a pretty good attempt from your side. Right? It was
Okay.
it was an easy question, easy to medium kind of question, but I would say the attempt which you gave it was good.
Uh,
So uh, going to the next part, which could have been improved. So the first thing I
okay.
just mentioned you that could have been improved. Right? The solution, although whenever I interview a candidate, I try to see if the candidate is implementing object-oriented concepts or not. Right? This solution doesn't mandate an object-oriented approach much. Right? I mean, you can do it, but then
Yeah.
it doesn't require to go that way. But yeah, so I could
Yes.
not test you a lot around object-oriented part. But one thing uh, that I also pointed out to you was that uh, the two method signatures are pretty same. So why to create two different methods? You realized it as well,
Yes. Yes.
right? But the point is,
Yes.
you could not come out with a solution, right? We had lost some of time, so we had to move forward. What you could have done is,
Yes. Yes.
rather than returning a void, you could have returned a node like this. And
Sorry. Sorry. Last part I missed. What should I have returned?
you could have just returned a node here rather than returning a void, and your base case would have changed a bit. If your base case and your if else condition would have remained same, you would have added one more condition here at end of your if else statement. And I'm on the Google Doc, sorry.
Yes. Yes.
So just follow my
So I
cursor.
should have returned DFS.
You could have
Yeah. Yeah.
returned
I
a
am there.
node here itself, the DFS, and
Yes.
moved
Yes.
this entire logic
Yes.
here. This is not
Yeah.
a
In one
red
method.
flag, not a red flag as such, right? Yeah, this is something which could have been improved. Right?
Yes.
So
Yes.
this was shown again in your BFS solution. If you could follow my cursor again. Right? So again, this thing was shown in your BFS solution. Another thing which we missed here is, what if the values are not present at all? What if you do not find them?
Yes. Actually, in assumptions, I asked, but like
Okay.
if I mentioned that I am assuming this, then also I need to take care of that.
Yes, I missed that part where you said you are assuming it. I
Okay.
would have pointed it
My
out.
question is if I
So if you're assuming it, you have to call it
oh
out loud. And you
yeah, I
have
called
to,
it out. I think.
Okay, you called it out. Okay, just
Yeah, yeah,
do one more.
I
So,
mentioned.
okay, I must have missed it. I'm sorry about that. I
Okay,
must have missed
okay.
it. So what you
No, no,
can
no,
do
no.
is,
It's okay.
what you can do is, you called it out very good. Uh, do one more thing, confirm it with your interview, right?
Yes.
Hmm? So yeah, I mean that one condition, I think that it should have been there, but my mistake. I should have noticed it.
Yes, yes.
But then I shouldn't have missed it. I did, right? So what
Yes.
there is one pointer to you. Even though the interviewer has made a mistake, but it may give, it may be a negative point for you.
Yes, yes.
Are you getting my point? So just make sure that whatever assumptions you are making, right,
Mhm.
get it confirmed from your interview. Or what we can
Okay.
also do is whatever usually uh, whenever you're making any assumptions, write them down.
Yes, yes, yes.
It is
So,
better that you
in
write them down. So the
yes.
reason is another reason is if you're giving an interview, the interviewer would be taking notes. They would be listening to you and taking notes parallel,
Mhm.
right? So let it be Amazon, Google, or any Facebook, right? Any company.
Yes, yes.
They would be taking notes side by side. So they may miss certain points, right? So
Yeah,
it is
yeah,
very
definitely.
human to miss. So let's say if you're making an assumption, you do not get a response back from them, or even if you get a response back from them, it's
Yes.
better to write it down because they may miss it in their feedback, or they may miss it, they may forget about it.
Mhm.
So it's better that you just
Correct.
write it down somewhere on the sheet itself, right?
Yes,
On
yes.
the sheet or whichever medium you're using.
Correct.
Google no longer uses Google Docs anymore. I'm not sure
Yes,
what Amazon
yes.
uses for
So
online
it
assessments.
has notepad.
Not exactly Notepad. They have a different environment. So
Yeah, yeah, similar to notepad.
similar to Notepad. I'm not sure what Amazon does, but yeah, but just try to write it down, right?
Yeah, yeah,
So
correct. Actually, uh, I want to call out all assumption on the first before I started to thinking about the solution. But I
yes,
have missed that also. Just realized I should ask clarifying questions more and the concepts and the assumptions earlier also.
right. So another thing which I another small thing, right? So the flat binary search tree. Just I would have liked it
Yeah.
uh, if you would have called it out as well. It's not a negative point.
Uh,
It's not a red flag, but
so calling
calling it out
uh,
as in it's a
calling on.
scenario. So when you're giving solutions here, when you're writing a binary tree on Jambo,
Yeah, yeah.
what you could have also done is you could have mentioned different kinds of trees which would have been possible,
Yeah.
right? Just an improvement
Yes,
feedback
yes.
here. It's not
Yeah, yeah. Sure, sure.
exact. It's not exactly a red flag. So I mean, obviously you wouldn't be getting the same
Yeah.
question, but whatever question you get, uh, so as an interviewer, I would be looking if you are checking the base cases or sorry, edge cases or not, right?
Hmm.
And while you're thinking about the solution, while we are talking about it, I would like you to also think about the edge cases, right? Just not when you're coding it,
Yes.
but also when you're proposing the solution, just point out all the edge cases. So it becomes totally clear to the interviewer what you're going to
Yeah.
do.
Yes, yes.
Okay. So, do you have any questions or feedback for me?
I think that's all from my side. I don't have any questions now.
So,
So, okay, okay, one more question, just last
yeah,
question.
yeah, sure, sure,
If I want to take more mock interviews,
sure.
so I want to just ask if you have any colleagues or if you have any connections that then they are taking even if paid mock interviews also, I would be fine with that. So
Uh,
if you would be able
Actually,
to suggest.
I don't know any colleagues who are doing mock interviews, but there I found a few websites where they provide where they do mock interviews. You
Yeah,
can check
websites
it.
I know, like Tramp and all,
Yes, yes,
but
yes.
yeah, but their budget is like very high, two
Is
fifty
it?
dollars or per three interviews they are taking. So
Oh, I
okay,
thought
I'll
it was
find.
free. Ramp was free, isn't
Actually,
it?
the Tramp is free, but for peer to peer. It's not
Okay.
free for like if somebody from Google will be taking my interview, mock interview, they will charge $100.
Oh my God. Acha.
Yes, and $1,000 for I think 12 interviews.
Oh, sh-
Okay, I'll take free. Six are free, but for only peer to peer. Like somebody peer will take. So that's fine. I'll figure it out somewhere. I
I'm
have scheduled
sorry
one
for
more
that, but
round.
I'm not sure if any of my
Okay.
colleagues are doing it. But if I find out, I'll broadcast it.
Okay.
But right now, I do not know if they're doing it.
Okay. Yeah. The fine, fine. That's fine.
Any feedback about this interview? Something I could help you with?
So feedback for you actually. Maybe I will just pop in LinkedIn message. I'll think
Sure,
means
sure.
I'll
Sure, definitely.
yeah, because now I don't find anything. I'll think about the interview and I'll just try to give feedback.
Cool.
So
I'm
are
with
you
you with.
interviewing you're taking real interviews also in Google?
Yes, I do real interviews. But
So
whatever
what
questions
would
I ask,
you?
I usually ask it from lead code or lead, so we do not use the question bank we have. So no luck around.
Okay, that's fine. So just you have given me the feedback that would be fine, but on the scale of like Google have higher, no higher, strong higher, what would you rate me for today's performance?
So considering this question, I would say, I would say higher.
Uh, that is
For a
3, right,
telephonic
out of
approach,
4.
what is 3 out of 4? So Google has a different scaling
Yeah.
strategy. So we just say whether we would want to hire them or not. Whether we actually want to hire
Okay.
them,
Okay. Okay.
it's fine if we hire them, or I'm not sure we can hire them, or we definitely do not want to hire them, or we
Okay.
do not hire them. So something like that, right? There are
Yeah.
some
Yeah.
scales
Yeah.
like that. So that is how we follow. Uh, I would have said that this particular question is fine for a telephonic round, I'd say, and
Okay.
it was since it was pretty easy, and you like I mentioned the positive points, right? So
Yes.
I would
Yes.
have said that you maneuvered through the question through the interview pretty well. So I would have said
Yes.
it
Yes.
is a higher. However, for
Okay.
on-site rounds, it would have been pretty easy question. The last question, which I thought was a bit difficult to think about, but you had already done that, so we couldn't take it forward.
Oh. Okay. Okay.
Yeah, so
The first
th-
first question, right? So
yes,
it was also easy. I think it was also a lead code easy problem.
it was it? I thought it was a hard problem. It could happen. I did not check it, honestly. I just remembered the question and found it on YouTube. Anyway,
Oh,
I will do some more research at
okay.
my part as well.
Yes, yes.
Okay.
Yeah.
Thank you. Thank you.
So
Yeah.
I think we have taken more than more time.
No, not a problem. No
Okay,
issues.
okay, fine. Yeah,
Cool.
yeah.
Thanks a lot.
Okay,
Thanks a lot
okay.
for the time, bro.
I'll ping you on LinkedIn, and thanks a lot from my side also to spend 2 hours almost of your time on weekend for this interview. So thanks a lot, and maybe we'll catch up some more if you have time.
Sure,
If
sure.
maybe, okay. Yeah, thanks. Yeah,
Bye.
thanks. Good night.
Good night.
Bye.